So, and how much time do I have? Like an hour or 45 minutes or 50 minutes or whatever?
We're good for an hour and a half at least.
Okay. Well, we'll see how long it takes. Okay, so on with the show. So the presentation has to do with a number of aspects about Amanitas, taxonomy and how to identify them, key them out by group. It's not always likely that you can know which species of Amanitas you have just because there's a lot of species, first of all, and there's also a lot of taxa that don't have a name yet. So, but that's okay because it's usually pretty easy to figure out which group yours belongs to. And so if you're concerned about it being poisonous, or if you hope it's edible, or you want to know something about it, you can usually figure out which section of the genus it belongs to pretty easily because they're, as you'll see, they're kind of easy to figure out. Amanitas, we'll touch on, if we have time, mycorrhizal lifestyle and some free living aspects. And for sure, we'll see lookalikes of Amanitas, which are kind of neat to know and just to find out why people get poisoned by Amanitas so much. But first off, in this club, do you say Amanita or Amanita? And I actually mean that. How do you pronounce it in this club? Because different clubs say different. Amanita? Okay, so well, whatever, if that's okay, Amanita. So I should say Amanita. Okay. Anyways, don't rush the stage and knife me. I'm not Dave Chappelle, and don't slap me. Despite the fact that, you know, maybe we disagree on how to pronounce different scientific names of fungi. As an example, so Amanita, Amanita, when I go over to Italy every year and lead Italy mushroom tours, my Italian colleagues and scientists over there who probably speak more, you know, probably have a better grip on scientific names than we do over here, they wouldn't pronounce it either one of those ways. So however you say it, as long as everyone knows what you're talking about, that's getting the point across. But however we say it, there's no denying that this group of mushrooms are very enigmatic, very characteristic of what people see or think of as a mushroom. They're the stuff of lore and legends. The Amanitas of North America book that my co-author and I did, probably the first third of the book is history and lore and things like that. So it's not necessarily taxonomy, etc. Everywhere you go, you'll see people getting excited about Amanitas because they're so big and showy and colorful, unlike a lot of other groups of mushrooms that are maybe small and drab, and especially Amanita muscaria. People get excited. Our European ancestors, of course, still to this day get excited and have festivals and parades, have Christmas ornaments on the Christmas tree. The Telluride Mushroom Festival, people dress up like their favorite mushrooms, and very often it's, of course, Amanita muscaria themed, but also very often not. Sometimes the Caesars and other Amanitas are shown. Typically, the awards for best costume are won by members of the Pikes Peak Club because they're usually on point when it comes to getting their costumes. So I think CMS needs to be representing, don't you think, Greg? Greg, wake up. So anyways, so some other things to cover in the presentation will have to do with maybe dispelling certain myths and other things you've maybe read in mushroom books over the years, like, you know, definitely avoid eating any Amanitas because they're all toxic, and that's of course not true. In fact, despite the reputation as being poisonous and killing people, which is very real, probably 90 to 95% of all mushroom fatalities worldwide every year are from Amanitas. Despite that, you probably couldn't name a genus that has more species collected as food and sold in markets and revered around the world. So, you know, in Europe, Africa, Southeast Asia, lots of Amanitas make it to the market because they're very popular edibles. Also, if you have an older book and it says how to identify mushrooms, and well, it can't be an Amanita because there's no trees nearby. Well, we now know that there's a few Amanitas that don't have this mycorrhizal habit and partner with trees. So that's also covered in the book, and we'll probably get to that tonight as well if I don't run out of time. So it seems that it's always obligatory to have a phylogenetic tree in addition to showing actual trees. So this is your one phylogenetic tree for the night. Actually, no, there'll be two. The next one will come right after this one. But anyways, just to show you kind of where Amanitas are on the whole phylogenetic scheme of mushrooms. They're a fairly recent arrival. Things like chanterelles, and some of the polypores, russulas came along a lot earlier. If you see the node of the tree where the ascomycetes and the basidiomycetes split off, the ascomycetes are things like cup fungi and morels and gyrometras, and then the basidios, of course, are rusts and smuts and mushrooms. Where mushrooms split from a common ancestor of ascos and basidios, that's about 350 to 500 million years ago. So fungi came on the scene quite a long time ago, but the group of agaricoid types, including Amanitas, came along much more recently. So these guys up here are all maybe from like 100 million years ago, but certainly before a lot of the land masses broke apart, and that's why we see a lot of really similar looking mushrooms in Europe and over here. And in fact, so similar that they pretty much all had the same name up until more recently when taxonomists decided to make things miserable for us by changing all the names that we learned. But that's the way it goes. So one branch on the tree to note is the one for the family of Amanitas, the Amanitaceae. It shares a branch with its closest relatives, the Pleurotaceae and the Pluteus type mushrooms. And in fact, although you're thinking about Pluteus right now because they'll be coming out really soon, usually around morel time, although you probably don't think of Pluteus as looking that much like an Amanita, or certainly not having the same sort of lifestyle. Pluteus are saprobes. Pluteus and their ilk are the closest relatives, and I'll show you some pictures in just a second. In any case, if you look at the nearest neighbor of the Amanita family, it's the Pluteaceae, which includes genus Pluteus and Vulva Pluteus and Volvariella. And again, they don't seem to share a lot in common, but when I show you some pictures, you might start to say, oh, yeah, they do kind of share some things in common. Within the family of Amanitaceae, there's this kind of oddball little genus Limacella, which really isn't worth pointing out. We do cover it in the book, but it's a small group and not often really seen, so they won't play in tonight's conversation. In any case, the genus Amanita is broken down into 7 sections based on various characteristics, which you'll see tonight in a whole bunch of pretty pictures. And in any case, includes things like the death cap that was covered in the poem and Caesar Amanitas and things like that. So we'll get to how these get split apart. But for now, let's look at some of the Amanita relatives like Pluteus. So again, these are outside of the family of Amanitaceae. These are the closest relatives, believe it or not, of Amanitas. And again, Pluteus is a saprobe. When you see this coming out in the spring, it'll be on wood, kind of a fawn-colored brown mushroom. There's white species, well, and there's even a few colored species, but most of them are fairly large, kind of brown mushrooms. But there's one thing about them, besides them being saprobic, that would easily distinguish Pluteus and Pluteus type mushrooms from Amanitas, and that's what? Exactly, pink spores. So when they first come out, the gills might be white, but give them a little time to mature and then they'll start taking on kind of a pink flesh. Otherwise, the cap itself is shaped quite a bit like an Amanita, and the stem even has kind of an Amanita look about it. But there's going to be the pink spores. Likewise, Volvariella are saprobes as well. This one even looks even more like an Amanita. You see it has a big vulva. This, the vulva is the big sac at the bottom that the baby mushroom pops out of, a big leathery membranous sac on Volvariella. And I think you have this species out here in Colorado, I want to say. I know I found it as far west as, on my way to Colorado, as far west as Nebraska and Kansas. In any case, quite a pretty mushroom. They are edible. I don't know why a lot of books claim that these are really, really delicious, because they're definitely not. I've eaten them numerous times, and I know people that have eaten them numerous times, and we all agree they're really not that good to eat. In fact, they're so pretty, I usually don't pick them. I usually leave them for someone else to see because they're just so spectacular. Has anyone seen these in Colorado? Okay, so there's some hands up. So they for sure should be coming out of hardwoods here in Colorado. And then there's one other group within this group of pluteoid types. There's Pluteus and Volvariella, and then there's a group right in between that Dave Hibbett erected a new genus for, Vulva Pluteus, so it's kind of in between. It used to be go by the name of, well, I guess the name's on it. Anyways, this is the Volvariella speciosus or speciosimus. Now it's Volvariella. So when you see this guy here, you're like, well, there's no way I would mistake this for an Amanita. It's got pink gills, of course. They all have pink spores. But what if that wasn't in the picture? Just focus on the left-hand side. For all intents and purposes, those look really, really similar to a death cap. You know, you could see that those do have a lot of similarities to an Amanita. And in fact, the babies even come from little eggs. This photo is taken in flower bed at our farm in Wisconsin. Ironically enough, on the day that the Wisconsin Mycological Society was going to have their big picnic at our house, big summer picnic, over 100 experts from Wisconsin. And so I put a bucket over this thing. I took the mature specimen away, put a bucket over it because I didn't want to pick them. And then had everyone come out to take a look at this. And every expert in the club, including everyone else, marveled over these, could not figure what Amanita it was. No one except one person knew it was not an Amanita. And this person was a very old person, probably the oldest person in the club. And she said, I used to see this all the time in Wisconsin in fields before they changed the plowing technique. There used to be a lot more debris in the fields, and farm fields in late spring, early summer would be covered with millions of these. And I said, did you eat them? She's like, oh God, no, they were terrible. And so I thought all books always list them as being edible. And in the Mediterranean, they're considered to be one of the most popular mushrooms. I've tried cooking them and they're awful. So I think maybe the one we have is different from Europe. Anyways, once I brought the mature specimen over, everyone was just stunned that this wasn't an Amanita. So everyone thought for sure it was a death cap. But there's one thing missing from this mushroom that tells you it's not a death cap. There's no ring. Otherwise, they look just like a death cap. So anyways, that's sort of the point here. There's a lot of mushrooms that look like Amanitas, and Amanitas look like a lot of other mushrooms that are safe to eat, so you can't be too careful. Here's a good example. This is Leucogaricus nascinus, the gray lepiota, or the graying lepiota, or the smooth lepiota. It has a lot of common names. David Aurora's Mushrooms Demystified calls it the fat woman on a bicycle, which possibly is the best mushroom name of all. I don't know why it's called that, but this was a big fruiting in northern Wisconsin one fall, and so this is the Leucogaricus here. So it looks quite a bit like an Amanita, and it's actually an okay edible. It's pretty bland. It comes out late in the year, lawn areas, about frost time. And it was fruiting, this mass fruiting on a lawn was kind of near this large tree. So there were lots of death caps fruiting under the tree. And there was even a zone where they overlapped. So for sure, if you had mixed in some death caps with your Leucogaricus here, you could run into some trouble. And the bottom picture there in my hand, I've intentionally picked that mushroom, much like someone in a hurry might do on a lawn, picking mushrooms, or maybe they're on someone else's lawn, picking mushrooms in a hurry so they don't get caught. So I intentionally pulled the mushroom out of the ground to leave its cup behind. Had the cup been on the bottom, you would have known it wasn't the safe Leucogaricus, but that's not how it was picked. So I intentionally robbed you of a lot of information here. And this is what happens a lot with people out in society and how they get into trouble. They pick something without being sure to note all the characteristics. Here's some other neat lookalikes. On the left is the Western destroying angel, and we have that Volvopluteus there with it again. And look what a dead ringer it is for one for the other. If you would look underneath of the Volvopluteus, no ring, the death cap will have a ring, although you certainly can't see it in the photo. They look similar. There's the Amanita there. The top right photo shows an Amanita called Amanita princeps. It's very, very common in Southeast Asia. It's one of the most popular edible mushrooms. And this, I believe, is the reason that Southeast Asians in the New World get poisoned by eating death caps all the time. Not because they think they're picking Volvariellas, especially in the case of Hmong people or people from Laos. A lot of books claim that a lot of the Hmong people think they're picking Volvariellas and these things. That doesn't happen. You wouldn't see the Volvaria in Laos. I've been there. And furthermore, people don't grow paddy straw mushrooms in Laos. Laotians almost don't really grow anything. They forage for most of their diet. So all of the mushrooms that Laotians eat in Laos come from the wild. And for sure, this mushroom came from the wild, and I ate it. That's Amanita princeps, and that picture was taken in Laos. This picture down the bottom right-hand corner is from California, and that's the spring Amanita in the middle. Amanita villosa, which a lot of books will say, well, you wouldn't get in any trouble with that coming up and being mistaken for the all-white Amanita ocreata, except, well, it's not always all white. So the picture is kind of washed out, but on my screen, it looks very true. And in the book, it looks very true of color as well. So they can be very light colored. Again, there's not going to be any ring on it, but for all intents and purposes, otherwise it's a dead ringer, so to speak, for the dangerous species of Amanita. Back to the Amanita princeps, that's a species of Caesar type Amanita, and a lot of Caesar types are popular all around the world. So I'll show you a few things about how it's actually easy to note Caesars. But I did have a very odd feeling when I was first eating these mushrooms cooked up, because they definitely look like destroying angels, and you just have even if you know what something is, you still have a stigma about it after all the years of learning not to do certain things and then having to unlearn it. This is another shot there on the left of Amanita princeps. It's a real pretty Caesar. And then on the right is a mushroom from Europe, Amanita ovoidea, which is a very popular mushroom with Italians. And look how similar that looks to a death cap. And whenever we see it, there's always people in the group that want to pick it and eat it. And I always say, how is it that people don't mistake this for a death cap or a destroying angel? Like, oh, I forget what the Italian name is. Oh, they just know what it is. And I'm like, well, how? And they're like, they just know. Like, okay, well, good luck with that. That's not really enough for me. Okay, anyway, so the good news is to identify Amanitas, unlike a lot of other groups, Gallerinas and Inosebes, and on down the list, Russulas, you don't need microscopy, you don't need a lot of fancy equipment, etc. You can usually pretty much figure out which Amanita species you have. And again, even if you don't know the exact species, you know which section of the genus it belongs to, so you can get pretty close. So, and the reason for this is because most Amanitas are quite large mushrooms and showy, often have very different colors about them, and they have pretty much all the different possible parts that mushrooms can have. So in addition to the cap and the stalk and gills, there's also a cup on lots of them. And if there's no cup, there's other material that's associated with, what this cup is, the vulva. There's a partial veil underneath the cap, which leaves a ring on the stalk, etc. Furthermore, they're so big that when you slice them in half, a lot of times they may be hollow or have something on the inside of the stalk, like this little baby one here. So a lot of things to look for. So just a couple things to point out. As we go on, we'll be discussing something called a universal veil and a partial veil, and a couple other things. So what's going on here is when Amanita mushrooms first start out as a little baby, people call them a button or an egg, it's entirely covered by a membranous covering called a universal veil. All Amanitas have that by definition. And as the mushroom elongates and grows and matures, that breaks, and it can leave behind a lot of really good information about what your species is. It can leave behind a single patch on the top of the cap. It can leave a bunch of warts. It can leave like a smeared covering of dust. And on the bottom of the mushroom, the bottom of the stem, it can leave behind a cup. The cup can be quite sturdy and membranous, or it can be very flimsy and break apart into pieces, or there may be no cup whatsoever. Maybe it's a bunch of rings on the base of the stem. And I'll show you pictures of all of these in just a second. But one other thing to note is covering the gills on the immature mushroom is the partial veil, and all Amanitas have this. All books point out that some Amanitas do not have a partial veil, and therefore they do not have a ring, and that's wrong. All Amanitas have a partial veil. It's just that the partial veil in the ringless species sticks to the stalk. I'll show you a picture and you'll say, oh yeah, I've seen that. Okay, so it sticks to the stalk when the cap opens, but they all have a partial veil. So just some things to note. So, and here's other aspects of Amanitas. So they all have a white spore print. White spore print for Amanitas is not going to really do you much good because lots of mushrooms have a white spore print. The gills will be white colored or maybe yellow, but if they're yellow, they're still going to be very pale. So in all cases, they're white to pale colored gills, not brown or purple like some Cortinaries, et cetera, et cetera. mentioned the universal veil, mentioned partial veil, and stalk and separates cleanly, cap separates cleanly from the stalk, so they have free gills. And what else to cover there? I guess nothing. So, and then I mentioned this thing about a lot of different colors. You know, if you are the type of person that's really into agaricus species, great. You really like white mushrooms because they're pretty much all white. If you like Inosebes or certain other groups of mushrooms, they're often all one color, but that's not the case with Amanitas. If you're going to the Namaphore this year, which is in Missouri, this time of the year when the foray happens in Missouri, you're going to be treated to lots of mushrooms, probably 300 species or more. It's going to be an excellent foray. Amanitas are no exception. 5 minutes in the woods, you see great diversity. That's where this picture was taken. Again, it took me 5 minutes, and you see a bunch of different Amanitas here. You may not necessarily know which ones you have, but you can certainly tell one's obviously different from the others. You see different cap colors. You see some with a bump on the top of the cap, an umbo. You see cups, and some without cups, some with rings and some without rings. Okay, so it makes it really easy to figure this group out. Here's the one thing for sure to know. If you're with the club collecting mushrooms for identification, and really all mushrooms, they usually stress bring in your specimens with some of the substrate, and that helps you figure out what it is. If you're a slicer and you slice your polypore off of the wood, well, now we're not certain what the substrate was when it came fruiting out of a tree. Likewise, mushrooms coming from soil, it's best to dig up, you know, not necessarily every mushroom you find or you're collecting for the table, you don't have to do this. But if you're collecting for identification purposes, this is a good idea. Dig up a little bit of the bottom of the mushroom. With Amanitas, it's really, really crucial because unlike a lot of mushrooms where you assume that most of the information is on the cap, you know, the color and the size and everything. Actually, with Amanitas, it's the reverse. Most of the information about identifying your species is on the stem, and in particular, the base of the stem, believe it or not. So these mushrooms here across the bottom show a wide array. A saccate vulva is a cup. The picture on the far left there, that's a saccate vulva. That's like a boot on that mushroom. It's pretty incredible. That's from the West Coast. And you see the one next to it, it has a vulva that's not very saccate membranous. It kind of crumbles and falls apart. And that's not because it's old. It just always is that way, and it helps you identify the species. Some things like Amanita muscaria and some muscarioid type mushrooms, and we'll see a couple pictures in a second. They don't have a saccate vulva. They have a basal bulb, a fat bottom to the stem, and then rings of material. This was the universal veil. It's just that it doesn't leave a cup behind. It leaves rings of material stuck to the stalk, and they'll do it every time. Amanita muscarias can look like a lot of other things, and they can even be different colors, but they'll always have the rings on the basal bulb. And then these guys here, these lepidillas, they don't have really any warts or cup or anything that would tell you there was a universal veil there when it was forming, but there was one, and what it leaves behind is just a bunch of powdery flecks on the cap and the stalk as well. But had you not dug these up carefully, you would have missed out on a lot of details. The guys here on the far right, if you had just sliced them off, look at this big monstrous, like, you know, turnip-like base to the stalk. I mean, that gives it away immediately what this mushroom is. So that's pretty impressive to see. So what's the reason for all these features, and why do they happen? Well, it's because when the mushroom's forming, we have cartoons like this in the book, which makes stuff easier to understand. I like cartoons. So when the mushrooms are forming, again, where the universal veil is and what happens next, and where the partial veil is and what happens next, that results in these different features you see on the mushrooms. So, for example, in section Amanita, which includes things like the fly agaric, Amanita muscaria, you end up having a basal bulb because the mushroom starts out little egg, the stalk elongates, but it doesn't elongate from the center of the bulb. It elongates from the top of that basal part of the stem. So you get a long stalk that leaves a lot of that egg behind. And so that's why the mature specimen has a big fat base to it. Likewise, this is the universal veil here. because of the material underneath the universal veil and on top of the cap, because it's kind of sticky. It's like a gelatin. If you were to slice the mushroom open when it's an egg, you could see this. It's like a gelatin there. So kind of the universal veil pieces stick to the top of the cap, leaves behind those scales. With other species, if there's a lot of that gelatin material, like the death cap and some of the other members of that section, there'll be a single patch on the top, but it can also just slip right off and there's no warts left behind at all. Likewise, the partial veil covering of the gills tears free from the stalk and leaves a ring on the side here. So, and we'll see cartoons like this later in the show as well. So I mentioned there's 7 different sections of the genus. So here's kind of a quickie thumbnail sketch of what they look like. So how to sort of key out or tease apart the genus Amanita is actually pretty simple. If you have your mushroom in hand, take a look at the cap, and is the cap striate or not? That means, are there like ridges on the top surface of the cap? And those ridges denote where the gills are attached to the underside. If it's really, really dry out, this can be tough in Colorado because you have drying periods quite often. So drying caps sometimes can look like they're striate even when they're really not. If your mushroom is striate, has straight margin to it, then it's in subgenus Amanita. It's on the left side of the screen. No striations, it's in subgenus Lepidella on the right side. If your Amanita, so focusing on the left-hand side, has a straight cap margin and a saccate vulva on the bottom, it's either going to be in the group with the Caesars or the group with the Vaginatae. It's easy to tell those two apart because Vaginatae do not have a ring, Caesars all have a ring. And the sacc's going to be white, but you don't even need to know the color. Otherwise, it's going to be in section Amanita, which includes, it's a big group, so you have your work cut out for you after you get to this step. It includes the Muscaria types, the Amanita gemata types, the panther types. So it's a really big group. Anyways, it's literally just that easy to separate Amanitas into different groups. If your cap was not striate, then it's going to be in one of these groups. So again, you go through the same process. Is there a saccate vulva or not? And is there a ring or not, etc. So let's just advance and see this key in action. This is from David Aurora's Mushrooms Demystified book, which is mostly about California mushrooms, but works the same in the East, works the same in the Rocky Mountains areas. So again, you take a look to see if your cap margin is straight or not. You can key to the left or to the right. On Aurora's picture here, his says inamyloid or amyloid. So if you're really experienced, you can do the Melzer's reagent test to see if the spores are amyloid or inamyloid. I never really bother because there's no point. It's easier just to look at what the cap looks like and see if it's straight. If the cap has a straight margin, the spores will be inamyloid. Do you know what this Melzer's reagent business is? Melzer's reagent is kind of an iodine type stain that stains for the presence of starch. So if the presence of starch is there or not will cause a blue reaction or no reaction, or even a dark kind of brick red color change. And you typically can test that on mushroom spores. Again, I never really bother. Okay, so let's just put this in action and see some of these pretty species and what they're called. I'll show you examples from Colorado, of course. We won't go through all of the groups because, I mean, we'd be here all night, but I'll show you some of the more important groups, and I'll show you some Western species and sometimes even show you some Eastern ones in that same group, but I'll for sure show you the ones from Colorado to be on the lookout for. And you'll say, oh yeah, I've seen that before, or I've never seen that before, and you'll know what to be watching for this year when the season heats up. Some will be coming out here pretty soon, kind of late spring. Most are going to be, like very late July through August when the big flush of mushrooms happens in Colorado. So this includes things like Muscaria types or Muscarioids, Panthernoid types, and Colorado Rockies area it's notorious for having some weird panther types, and also mention the toxins of this group. So from the west, we have an Amanita muscaria, the fly agaric, that's known as variety flavivulvata. It's called Flavivulvata because flavi means yellow. It has a yellow vulva, the covering over the mushroom. So how would we know that? These are mature. Well, we would know that because remember the velar material that's left behind, the scales and warts and rings and these sorts of things, that was the universal veil. And well, we can tell what it is because it's actually yellow on the margins of the scales. This was the yellow covering over the Amanita. Well, okay, big deal. I could have guessed that. Well, there's some other places where you'll see this yellow universal veil material on the mushroom, and that's how you know that's this variety of Amanita muscaria, not some of the other varieties. So if you look at the rings, the ring is white, right? Except for the very edge, it's yellow because that was attached to the universal veil. Likewise on the stalk, it's kind of washed out here, but there's 3 or 4 rings of yellow velar material on that fat basal bulb on the stalk of the mushroom. And so just to recap, how that happens is when the mushroom goes from that little baby, the little egg, and it breaks that universal veil, that material is left behind on the top of the cap as scales and warts and as rings of material on that fat basal bulb. So the muscaria you would see out here would be red most of the time. It doesn't have to be. It could be yellow or white. Has anyone seen Amanita muscaria in Colorado that was yellow or white? Oh, great. There's actually a bunch of hands. So usually when I mention like, well, no, it can only be one color. So yeah, it's great. So you can have red or yellow in addition to, red or white in addition to, yellow or white in addition to the red. In the East where I'm from, our variety is Jasowii, or if you have older books, it's called Amanita muscaria variety Formosa. That's the name I learned it as. Formosa means beautiful. And to me, this is what a really beautiful Amanita muscaria looks like. They're usually yellow, maybe a little orangish in the center, but this is what they look like over by me. And muscarias can occur with all sorts of different host trees. In the East, very common with white pine, but can be other species out here in Canada, out here in Colorado. Sorry about that. Out here in Colorado, they can be with a number of different conifers as well. In the Pacific Northwest, Alaska, and a small area in California, I think now has reported this, and also I think a small zone in the East Coast, we actually are seeing this European Amanita muscaria coming up, variety muscaria. So this is the true, in quotes, Amanita muscaria. This is an invasive species, and I've seen it everywhere. I've seen it in Australia, South America, of course, Europe, and pretty much anywhere. It seems to be able to jump to all sorts of different hosts. You'll see it in plantations of conifers, like European conifers or North American conifers in South America, or planted in New Zealand or Australia, and where there's a lot of the mushrooms haven't yet figured out that this new tree host that they can partner with, you'll see, the whole plantation covered with millions of Amanita muscaria. So it's kind of cool to see, but at the same time, it's a little unnerving to know what a mushroom like this will do, because it does seem to be pretty aggressively invasive. So if it spreads into other native trees, will it force out other native species of mycorrhizal mushrooms? We don't really know just yet. So stay tuned. More good news, more invasives. So, and I forgot to put this slide in here. So I mentioned you can actually see all 3 different colors of Amanita muscaria, sometimes if you're really super lucky. You see the striate margin here. A lot of times you don't notice it on some of the other ones because they're covered with scales on the margin of the cap. So some of the Amanita species we'll see tonight have extremely deeply striate cap margins. In fact, the majority of the cap is striate, and it's very obvious. With muscaria, it's never very much. It's usually only about 5 or 10% of the cap. So just kind of the edge shows that striation. So the first one, in addition to muscaria, to be on the lookout for around here will be this guy, Amanita alpinicola. And this is a fairly newly named species named by Kathy Cripps. It's a very pale yellow species at very high elevation. She studies subalpine trees, and this one goes up all the way to tree line, and typically occurs with a couple different conifers. The other thing about it is it often goes unnoticed because it has the habit of, as it's erupting through the soil, it doesn't really make it through all the way. So you'll see kind of mushrumps where it doesn't really break the surface. Not sure what the point of that is, because the mushroom really needs to get its spores out into the environment. Maybe it has some sort of a vector that digs them up or eats them or something. But this is in the same group with Amanita muscaria, so you'll notice very similar, a lot of similarities. It has the bulbous base and some rings of velar material on the stalk, and also the warts on the cap, much like Amanita muscaria. Anyone ever seen this one before? No hands. So this is definitely one to be on the watch for, because Kathy wants to know what its range is. So if you are out and about early in the season, you might be watching for this thing. More notable from Colorado are the different Amanita pantherina types. In the West Coast, I think it's still debatable whether we have true Amanita pantherina or if that's just a European species, but we have a number of pantherinoid types that range from really dark chocolate brown in the Pacific Northwest, which is really similar to the so-called true Amanita pantherina from Europe, which is a very dark chocolate brown, really pretty mushroom. And then it seems like as you work more and more eastward, the pantherina type species get lighter and lighter. So as we get into the Rockies, the species here is kind of a more tan color. I'll show you one in a second. But first I want to point out, besides the brown color, and again, that's really not the best feature because they can be lighter, but they will have a bulbous base. And instead of like the 3 or 4 rings of velar material like the muscarioids do, the pantherinoid group of Amanitas has basically a single ring of velar material. And in fact, it's a very pronounced single ring to the extent that it's like a collar. It looks like if you had a sock and rolled the sock down your ankle, it kind of rolls over, and it's a very prominent single ring. They call this a cothurnate stalk base. It's on Jameta types as well. You can see here, this slide shows us a little more prominently. You can see there's a single ring on these guys. It's a very prominent collar at the bottom of this cute little basal bulb. In the east, we have quite a few different species of Amanitas in this group that have this cothurnate base, like Amanita reticuloides. Out here, not so many. Here's the Colorado Rockies panther, which up until recently was called Amanita pantherina variety multisquamosa. It's now been elevated to its own species, and now people aren't even sure about that. Maybe there's probably multiple different mushroom species going by this name. A couple things to note. It does have this small basal bulb, has that cothurnate collar of material at the base of the stalk. It also has a ring, of course. The ring on this guy is not that high up like Amanita muscaria. It's usually about halfway up the stalk. And you can even see on some of these, it's not even. So this is a neat character to look for. Not many Amanita species have a ring that's half or less than halfway up the stalk. That's usually pointed out in books. Because that's kind of an unusual characteristic. Anyways, these guys can occur with a number of different trees. I've seen them with aspen as well as conifer. So that means, like 5,000 feet, but also up even much higher than that. I think this picture here I took at Kenosha Pass. That's often a place where I would stop off on the way back from Telluride and take a break. And there's, if you've been to Kenosha Pass, there's lots and lots of mushrooms there. In the east, we have something similar, which also is called Amanita multisquamosa. Not sure if it's the same thing, but certainly has this cothurnate collar and then that ring that's only about halfway up the stalk. Michael Kuo, who I think you probably recognize that name, he calls multisquamosa the white panther or the light colored panther, which I think is a pretty neat name. It's in the panther group. It's not dark chocolate brown, and it has all these wart-like spots on them. Pretty much. We have a number of others in the east, as I mentioned, but I won't show you all of those since no need. Let's move on to the Caesars, because they are pretty much the most colorful group. They're certainly the most famous, maybe of any group of mushrooms as far as edibility. at least in Europe and Southeast Asia and Africa. So this species here is not one you're likely to encounter around here. This is the Cocora from the west, but the Caesar type Amanitas often are this real pretty orange or reddish, or kind of a tomato orange red color, real pretty. Some other things to note. All the Caesars, or nearly all the Caesars, have colored gills, very pale yellow gills, also have a yellow stalk and a yellow ring, but will almost always have a white saccate bulb at the bottom. And all the Caesars are considered edible. I guess I should back up. The previous group, all of those should be considered poisonous. It's not the same poison as in the death caps. They're not known to be deadly, but muscarias, jamadas, and panthers are all considered to be quite poisonous, and you really shouldn't eat them. I know some people, for one reason or another, like to eat Amanita muscaria for perceived psychotropic properties, but they will make you pretty sick if you're not careful. They can be detoxified by boiling out the toxin, but then you pretty much have a bland mushroom. So that's also seems kind of pointless to me. Anyways, the Caesars, you'll notice from this picture here, very prominently striped cap margin in addition to the bold colors. I'll show you a picture of one or two that are not colorful, that are more a light color, but a lot of the ones in this group are colored. And again, these are some of the most popular edibles. You go to Italy during the summer and fall when the big flush of mushrooms is on, of course you'll see king boletes for sale. Everyone knows Italians like king boletes. The porcino mushroom is wonderful. And if any of the porcini of North America are as good as the ones in Italy, it's for sure the Rocky Mountain king bolete. So if you've never tried one, make sure and get out this year. But as good and as famous as king boletes are, and chanterelles, and a lot of different mushrooms Italians eat, the ovuli, or the Caesar Amanita, is the favorite mushroom, and it also fetches the highest price, and especially when it's in the little egg form. And the good news is we have a Caesar from out here, which is one of my favorite mushrooms to eat, and it's beautiful. It's this Amanita cochiciana. It doesn't even have a formally published name. This is a provisional name, but it occurs with mixed forests, especially conifers, not super high up. I think like maybe 5,000 feet or below that even. You won't see it very high elevation, but it can fruit in profusion, and typically its color is a very yellow color, sometimes gets this orange on it, but you'll note there in the picture the colored gills as well, and that white saccate vulva. Has anyone collected these? The Four Corner Caesar, or the Sun Caesar, they call them in Arizona. Okay, and what about the taste? Did you love these? Yeah, they're great. So the thing is with the Amanitas, so mushroom guidebooks as well as mushroom clubs, when you first join, by the way, how many people are like total beginners and newbies? Oh geez, everyone. Okay, so maybe I should start over. So Greg, you didn't tell me. Has any of this, none of this has been over anyone's head though, right? You don't need to be a scientist. Okay, it's pretty pictures. So when you join a mushroom club, or pick up a guidebook and you decide you're going to start collecting mushrooms and eating them because it seems like the thing to do, the first thing they always tell you is do not eat Amanitas. And then the second thing is do not eat what or how? Raw mushrooms. Yeah, they always say this. Do not eat Amanitas, do not eat raw mushrooms. So leaders of this group, avert your eyes from the next slide. Because with the Amanitas, I do not recommend cooking them unless they're great big ones. Italians would never cook them because frankly they kind of fall apart and lose their flavor, and actually even kind of take on kind of a fishy smell and a fishy taste. So Amanitas are best served raw, and when I'm talking Caesars here. So in Italy, this is how you'll find Amanitas prepared for you, ovuli style. Ovuli sort of means like egg style because they look like eggs. They'll just put them chopped thickly onto a simple salad with some good olive oil, a little bit of lemon juice, and some salt. And it's quite wonderful because the mushrooms are extremely aromatic. And this isn't the only mushroom that, in my opinion, is best served this way. Small king boletes also are best served this way, in my opinion. I'll usually use like a truffle shaver and shave super thin pieces all over a salad. It's very aromatic and wonderful. They're raw mushrooms, so yeah, there's a lot of fiber there. They could upset your stomach if you eat like 5 pounds, but if you ate 5 pounds of raw broccoli or 5 pounds of apples, same thing, a lot of fiber there. It doesn't mean they're not edible, and it doesn't mean you can't get nutrition from them, because yeah, a lot of people mistakenly think that you don't get nutrition from mushrooms unless you cook them, but it's kind of similar to eating plants. There's a lot of indigestible material of the cell walls, but you're not eating things for the cell walls, you're eating it for the goodies inside and the flavor. So if you haven't seen ovuli prepared and you do see these baby sun Caesar eggs, give this a try. Absolutely make sure that you know what you're picking, but there's no dangerous amanitas that are, you know, orange or red colored. So it should be pretty hard to get into trouble. Now, having said that, one of my favorite of all Caesars grows on the West Coast, and it's a very light colored Caesar, and it does look just like death caps. And in fact, it fruits at the same time as death caps. This picture's in the book to show how similar they can be. So which one's the death caps? And which one's the super choice edible? I'm not going to tell you. Okay, I'll tell you. So even if I did tell you, still the ones I tell you're edible, it's still pretty dang close, right? So the death cap is which one? Deadly or safe? Death cap. Deadly or safe? Okay, deadly or safe? Okay, deadly or safe? Okay, deadly or safe? Wow, you survived. You survived to eat more mushrooms. So, but anyways, everyone here either knows about mushrooms or at least knows some stuff about mushrooms, but you can see how the average person that literally knows nothing about mushrooms but saw a TV show or something and decides, oh, I'm going to go out and pick mushrooms, how they can get into trouble, because they can, for many people, look identical. So here's one other thing about knowing between death caps. We haven't got to that section yet in Destroying Angels versus Caesars and some of the other edibles. So besides all the other features I've pointed out, there's still one more feature I haven't even told you about yet, and that's the feature on the inside. If you slice Caesar mushrooms in half, and the same with the vaginatas, the stem is hollow. Death caps and Destroying Angels, the stem is solid on the inside. Most of the time. No, it's always solid. So here's another thing to point out. If you are a beginner, you typically start out with the so-called foolproof 4 or foolproof 5 mushrooms. So that's going to be what? Puffballs. You're literally naming like there was 20 mushrooms there. Okay, so foolproof 4, puffballs, morels, shaggy manes, and chicken of the woods. Yeah, so I don't think any book calls a chanterelle a foolproof 4, especially since people get poisoned every single year with things that they think look like chanterelles. But puffballs, morels, chicken of the woods, and shaggy manes, those should be the foolproof 4. Because there's stuff that looks like chanterelles, there's stuff that looks like oyster mushrooms, et cetera, et cetera. Anyways, when you start out, puffballs is often the mushroom people start out first, right? I mean, even the newbies, you've probably eaten a puffball or no? Who has not eaten a puffball? Oh, that's good. So I'm here to tell you, don't bother, because puffballs are awful. But if you're a beginner, there's not much that looks like them, except sometimes there is. So if you bring your puffball home, and this is what all clubs will tell you, and this is correct information. So if you bring your puffball home, you know, they're white, you slice it in half, it's white throughout, totally safe to eat. A true puffball, as they over mature, they'll get kind of brown and gushy on the inside because they're starting to create this big sack of spores, and then they're not. You shouldn't eat it. Well, frankly, they look gross. But if it's white, solid white all the way through, puffball. If you get your baby puffball, so this guy was holding a puffball here, and he was like, "Yeah, what is this puffball?" And I'm like, "You want to slice that puffball open?" So he sliced his puffball open, and on the inside of this white puffball, look, behold, there was a baby mushroom. So if you slice your puffball open and there's a mushroom inside, it's not a puffball. So it could be an amanita because they have this little egg. It can also be a stinkhorn because they form from sort of an egg-like thing. So either way, you could be in for a surprise. This would have been a safe bet for this guy here because you can tell it's a Caesar amanita. You can see it has this bright orange-red cap, even in this little baby mushroom. But if it was a destroying angel, the mushroom would have been the skin of it would have been white, so you wouldn't know necessarily what species you had. And in fact, it might even be hard to tell there was a mushroom on the inside. So, you can't be too careful even with puffballs. So just point that out that even the baby mushrooms, they can be sliced in half, and you could tell. On the left is the Sun Caesar from Colorado, and the right is a Sun Caesar costume from Colorado, and a little baby egg there, just because that was a good costume. So a couple other mentions in this Caesar group, and you could find these around here, at least one of them, you could find around here, but they're not often seen because they're so teeny. Look how tiny these little mushrooms are compared to that penny, or compared to this little stick here. But these are mature specimens, very straight cap, a sac on the bottom, a little ring. These are mature mushrooms, but look how tiny. So these two species here, Pachyperma and Virginiana, these are the smallest amanitas we have in North America. And despite their tiny little pint size, they have the largest spores of all amanitas, including that Pachyperma. It has the largest spores of all amanitas in North America, even though it's the smallest one. I always find that curious. I don't know why that should be, but it's just a kind of a curious thing. So you could see these little guys around here, but again, they often go unnoticed because they're so pint sized. Okay, so our final section in this subgenus Amanita with the striate cap margins is the grisettes. And this is another group I wanted to spend quite a bit of time on because they're so pretty, and they're also all considered to be edible. They look quite a bit like the Caesars because they have this saccate vulva, but no ring. So, and I mentioned at the outset that by definition, all amanitas have a partial veil, that veil that covers the gills of the immature mushroom, but that with this section, the partial veil doesn't tear free from the stalk and leave a ring on the stalk. The partial veil stays stuck to the stalk. So you can see partial veil here in this cartoon, and then when the mushroom matures, the partial veil material is on the stalk. So these mushrooms often have really, really pretty stalks with different colors, or they look like rattlesnake skin or something like that. So that's a neat group. It's also a neat group just because it's probably the largest group. There's lots and lots of species in this group, and probably half of them don't even have names yet. So this is where a lot of science is actually being worked on. The so-called Amanita vaginata, who really knows if there is a single species in North America that's called that. So we typically call them all vaginata group if they have no ring, a cup at the bottom, and kind of a gray or gray brown stalk. But the exciting thing is on the stalk, you can see it has this sort of white velar material that looks like a rattlesnake skin. Some of the species in this group, like this big Western Pachycolia, has a big, giant, massive boot. And we have some species in Colorado, I'll show you in a second, that also have a pretty good size honking boot on them. And that's the saccate vulva. Probably my favorite Amanita from this group, in fact, it's one of my favorites of all, occurs out here in the Rocky Mountains only, and it's Amanita stania, the tin hat or the tin Amanita, which typically has this gray colored cap. It can be kind of a light silvery gray, it can even be a very dark gray, especially if they're occurring in a dark part of the woods. But the universal veil on this mushroom is white, And as it ages, it takes on these ochre stains. So you can see the velar material that forms the vulva, as well as the scales on the top have kind of an ochre stain about them. Last year was an especially good year for them, so I got lots of great pictures, some of them quite dark specimens, which are just stunning to see. Has anyone ever seen this mushroom before in Colorado? Yeah, it's something to be on the lookout for. So this mushroom was first named, this isn't even a published name, this is just a provisional name, Amanita stania, was first named a long time ago, like 50 years ago, and pretty much forgotten about. I think it might have been the first or second year I was at the Telluride Mushroom Festival. I found some of these, and I had no idea what they were, and showed them to Gary Lincoff. And he's like, "Oh yeah, we always see that out here at the Telluride Mushroom Festival. That's called Amanitas stania. You won't see it in any book because it's not really been published, but it's a pretty cool mushroom that I think it's an Alexander Smith name." And sure enough, we do see it every year. And this last year it was a treat because there were so many, but also so many of these dark specimens. So how about the velar material on the cap? Doesn't leave behind a bunch of warts or flecks or scales like the Muscaria types. It leaves behind maybe a single great big skull cap, or maybe a few large patches. But they always have this ochre staining to them, just as does the saccate vulva. And one more shot of them. So real pretty. So another species from this group that's quite a bit more common out here is Amanita borosii. Oh, so stania, I have to point out, occurs with conifers, fairly high elevation. Amanita borosii occurs with aspens, so usually not terribly high. I think this picture here was taken with Brian Barzee at Pikes Peak, I want to say, because we've had good luck finding them over there. All the mushrooms in this group can be considered safe edibles, and this is one that I know a lot of people actually eat if you find a lot of them. Some years at Telluride, there's thousands and thousands of them found, and they can get quite large. Always have this white cup at the bottom. The color is going to be kind of this orangish, peachish colored, and it's pretty tasty. So another neat one, which most people would consider rare because it's rarely seen, even though it's probably super common, is Amanita populophylla. This occurs from the Rocky Mountains through the prairie states and on into sort of the western edge of the Midwest. So we'll see it in Minnesota and Wisconsin. I don't think in Illinois, but for sure I've seen it in Wisconsin and Minnesota. So it's common, but why don't people see it? Well, because it fruits only with cottonwood trees, and especially the eastern cottonwood. And if you know about their habitat, they typically grow in kind of wet, almost swampy areas. And why would you look for mushrooms there? Mushrooms are not going to grow in this habitat, except this species does. So it's probably a lot more common than reported. The color here is kind of washed out. It's kind of a light tan, buff color to almost white color. And it usually does not fruit singly. It usually fruits in pretty good profusion. Some places they'll be kind of spindly, other places they can be quite a large honkin' mushroom. Has anyone seen these out here? Yeah, and did you eat them? So, okay. But yeah, it's pretty cool to see, especially when it's around a cottonwood and you're like, what fruits with cottonwoods? There's not that many mushrooms that partner with cottonwoods. So here's another one to be on the lookout for. And this actually applies no matter where you are in North America. Be on the lookout for white forms of Amanita vaginata. So you could tell this is vaginata, striate. Again, I don't know what species this is. That's why I have it close. But I know which section of the genus it's in. Striate cap margin and saccate vulva, and no ring on the stalk. So these forever, whenever they're seen, which is not common, they just go by this name Amanita alba, because there is an Amanita alba in Europe. But the ones in North America, according to Rod Tullis, there's probably quite a few different species that go by this name, and they're very poorly known because they're rarely seen. I know with Brian at Pikes Peak, we've seen all white Amanita vaginata type there. So just be on the lookout. If more are collected and sent to a fungarium and they can do some DNA sequence analysis, maybe some of these can have a name put on them sometime. So there's a few in the upper Midwest that I've been on the lookout for years as well. So something to watch for. This is probably, I think, the last one from the group. Amanita greenlandica. This is a mushroom that occurs all around the entire globe in the far northern hemisphere at high elevation and high latitude. Amanita greenlandica. Kind of a medium to smallish little dude that is mycorrhizal, and its tree, in quote, hosts usually are smaller than it is. So Arctostaphylos and other weird little kind of Arctic scrubby little tree-like bushes that kind of grow close to the ground, because the Arctic is kind of harsh and windy and drying, and you have a lot of really kind of shrinky-dink plants. Well, this mushroom is one of those few species that can be seen towering over its tree host. So kind of makes for kind of cool photos. This is Kathy Cripps right there in the background. And you don't have to have a helicopter to get to where they are, but I guess it helps. So that's another one to be on the lookout for, because it is known from a lot of the Rocky Mountain region. So how are we doing on time? Okay, so what's that? Okay, yeah, well, I think this is the last section I'll cover anyway. So, you can't have a presentation on Amanitas without discussing the death caps and destroying angels. This is section Phalloideae, and they're the most notorious group. I mentioned at the outset that 90 to 95% of all mushroom deaths are from species in this group, and in particular, one species, this non-native species we now have in North America, Amanita phalloides. So section Phalloideae members all are white except for death cap and some from Central America and a couple oddballs. So it makes them kind of hard to know one from the other, but you can tell species in this group because they have this very prominent saccate vulva. It doesn't get super tall like some of the species that I've already showed. The base down inside that cup can be somewhat bulbous, also has a ring, of course, and often a single cap of a single patch of material on the cap, or maybe no material on the cap. The death cap, Amanita phalloides, very often has none, and in fact, a lot of books point out that there's no velar material left on the cap. So, naturally, in our Amanitas book, I made sure and showed lots of pictures of death caps that did have velar material in the cap, because if you see enough of them, you'll for sure see you'll see this in the forest. So we don't know of this mushroom being in Colorado yet. We do know that there are destroying angels in Colorado, and we do know that as of last fall, Amanita phalloides is known from Idaho, so it's coming this way. And this was confirmed by DNA sequence analysis. So if it, as Idaho goes, I'm sure Colorado goes with this mushroom. So book descriptions will say this is usually kind of a light chartreuse green as opposed to white of all the other destroying angels. Well, actually the color, if you've seen enough of these, the color can range from completely pure white to cream to that kind of yellow green chartreuse color to brown and even, bronze and even dark brown. The ones here in my hand were from a great big clump this was taken from the East Bay area of the Bay Area in California. And they'll often have massive fruitings in the wintertime of these things. So I was on a hillside where there was for sure millions of these, but there are big clusters coming out of, maybe a dozen specimens at a time. So I grabbed a bunch from this one cluster, and you can see the color variation just of members that were basically all attached at the bottom coming up at the same time. So the color can be quite variable. The stalk often has the same color as the cap, but the cup usually is a very pale color or white, and it will have a ring, of course. All the other members of section Phalloideae, again, will be white. Maybe there's yellow at the center of the cap, but otherwise they're mostly pure white. So this is Amanita bisporogyra. This is the species that typically gets blamed for having the death cap seen all throughout the East and on into Colorado. And I'm not really sure if that's the case. Bisporogyra actually, besides having only 2 spores per basidia, is a pretty small mushroom. So I think a lot of the other destroying angels we have that go by this name, they're probably something else, some of which don't have a published name yet, or maybe they're like this one from the Midwest, Amanitas suballiacea. This is our most common large destroying angel. In the upper Midwest, where I do a lot of my collecting, we for sure have 4 or 5 species of destroying angels. All of them look pretty similar. They're all completely white. This one gets the biggest, and they can easily be, well over a foot tall and just massive. You can see the knife in the picture. This was taken at a wayside. We have a lot of these county roads that kind of go all over the Midwest, and they have these little stop-off areas where you can picnic, or maybe they have like a pit toilet, or maybe they have one or the other. Anyways, I stopped off because the waysides, if you came to the NAMA that was in Wisconsin, that was the one that I organized. This was collected near where the NAMA foray was. Anyways, these waysides are great for picking mushrooms because they mow the grass, and there's usually great big giant oak trees and things. So they're great for collecting. You can see all the mushrooms that are there in just like a minute. Anyways, there was a guy with a big basket. He must have had about 100 of these. When I pulled up and I said, "Wow, what are you picking?" He's like, "Oh, look at these mushrooms." I'm like, "Yeah, and you know what they are, right?" He's like, "I have no idea what they are. I just know I'm going to take them home and cook them." I said, "Well, you will for sure be dead tomorrow, without a doubt." So I assume that nobody knows who anyone is. So I, showed him business card and everything. And I said, "I'm not a crank or anything, but I'm just trying to save you a lot of misery. And here's what this mushroom is." And we, went online, and he's like, "Oh my God, I can't believe it." So anyways, it's great to see because they're such a pretty mushroom. They get really, really big, but yeah, it's definitely not something that you want to eat. So that's Subaliaceae. Again, I mentioned there's a lot of different destroying angels. It's tough to know because they're all white. So there's a couple things you can do to tease apart some of the species. One is the addition of a chemical called potassium hydroxide. And for sure, someone in the club probably has this. If you do find one of these white destroying angels, and I think some were just found last year, the year before, it made kind of big news. So they're around. Anyways, if you want to try to figure out what it is, that would be pretty cool. So if you add potassium hydroxide, KOH, you'll get a real bright, intense lemon yellow color within just like 60 seconds. And that can help you determine if you have a species that's KOH positive or negative. Okay, what's the big deal? Well, you can see from this picture here, I can quickly determine Subaliaceae, which is KOH positive, from another species we have in the east called Elliptosperma, which is KOH negative. So I have a little dropper bottle and just kind of drop and smear the cap with this material. And where I basically scraped the cap here, there's liquid on there. It's clear, and there's liquid on there. You can even see it's wet, but it's not causing a color change. So this species is KOH negative. And this is very helpful because Elliptosperma looks like this other destroying angel that's like its cousin called Magnavalaris. And that's really the only way you can tell them apart is with this chemical. So Subaliaceae, there's some other ways to know it's not this species, but anyways. So there's some other tricks you can do as well. So well, what makes these guys so deadly? So within the genus Amanita, mentioned the Mascarioid and Pantheroids, they have one type of a toxin. The Lepidellas, which I'm not covering, they have a different type of a toxin. Neither one are deadly. This group, section Phalloides, he has a third type of a toxin, and they are the ones that are deadly. They have this compound called alpha amanitin, or these groups of compounds called amantins collectively. It's this great big ring molecule structure, which all the members of this group are thought to produce. No one really knows why they produce these big giant cyclopeptide ring molecules. Maybe they're precursors to other molecules. We don't really know. They are, of course, deadly poisonous to humans and many other mammals, but not all other mammals. They're also probably not really poisonous to any other animals at all other than mammals. I mention that because all books say that they're poisonous for everything. They're not. The organisms that I've studied for 30 years are flies that have co-evolved with mushrooms. They feed on mushrooms. So when you pick mushrooms and there's little maggots in the mushrooms, yeah, that's what I study. So dirty little secret. So now you know. Don't hate me. So anyways, they're not, those flies are not affected by this compound. So we don't really know what this poison does. it also doesn't seem to be one of those things where it's like an anti-fedant, because it doesn't kill you right away. You can't taste it. It's not like a lot of different bitter alkaloid compounds that plants have that are poisonous, but they're also bitter. And you get a bite of this thing and you spit it out, and then you quickly learn not to bite that thing. If you got poisoned by this, you wouldn't know what poisoned you, because you're not going to be sickened until like the next day. So I don't think it's, to be teleological, I don't think it's purposely in them as an anti-fedant. I just don't know really what it does. But for sure you should avoid them. So for longest time, there was a test to determine if your mushrooms had amatoxins, and the test is awful. It involves using concentrated nitric acid and newspaper, and not just every newspaper. It had to be like cheap newsprint. It didn't have to be a newspaper that showed that your team just won the national championship in football. It could be any type of a newspaper. This was fortuitous. Someone brought this to me. I was about to do a test at the Santa Cruz Fair, and they're like, "Oh, I guess you saw Clemson won last night." And I said, "Yeah, I did." So it was a terrible test, but there's good news. Just recently, a scientist in California developed a spectacularly good test for amatoxins. In fact, it's so sensitive that it's not even really for testing mushrooms. It's for testing to see if people have ingested amatoxins. It's so sensitive, you can take a couple drops of blood out of someone that's suffering from something, and you could test that blood and see if they have amatoxin, or their urine. Isn't that incredible? This other test could never have done that. And it works just like a home pregnancy test. So I don't have any with me because I didn't think we would find Amanitas, but I do have the test, and I've done it with clubs, mushroom clubs, and they were extremely impressed. This one was done last fall in Missouri or Texas, somewhere down the south. I forget where we did it. Anyways, we had deadly Amanitas. We had false death cap Amanita that looks deadly, but it's not. We had Gallerina. You say Gallerina or Gallerina? Okay, yeah, we had those and a number of other mushrooms. So we did the test for amatoxin, and sure enough, the Gallerinas, tested positive. The deadly Amanitas tested positive, and everybody else tested negative. So to do this test, if you see this online, it's called amatoxtest.com or something. You can buy them. They're packaged and they can sit on a shelf forever. Has a little Eppendorf microfuge tube in it. You take a piece of a mushroom, it can be fresh or dry, a tiny piece of a mushroom, and just put it into an amount of water. It doesn't matter how much water. Shake it for a minute, take 3 drops of that water and put on the test strip. And it's so positive you'll have results in 60 seconds. It's so sensitive that you can't handle the poisonous mushrooms and then handle the non-poisonous mushrooms, because you'll get a false test, a false positive. It's that crazy sensitive. So if you're thinking this would be a good thing for the club to get, amatoxtest.com, I think is the name of it. Pretty cool. But for sure, hospitals in parts of the country where they have dangerous Amanitas, this should be something to think about. Okay, and so that's been about an hour. So I will stop there, and thanks for your time.
So I'm gonna turn on the house lights. Does anybody have any questions?
Did anyone have a question? Okay. So the question is if you are poisoned by amatoxin containing Amanitas, what is the treatment? So the treatment is, if you suspect early enough on, you can go get your stomach pumped, and they'll pack your stomach full of charcoal. It's not pretty, but it could save you. And then they usually flush your body with lots and lots of water and lots of irrigation, just try to dilute it and keep the person calm and restful, and maybe have IV with fluids and stuff like that. Part of the problem is when people get sickened from the Amanitas, then you get frightened and scared, and it speeds up your system and causes even more problem. Here's what happens. If you're really interested, the whole series of what happens, the whole gruesome details are all in the Amanitas of North America book. But what typically happens is you eat the mushrooms and are feel just fine. Maybe 6 to 12 hours later, you have extreme gastric upset and you are vomiting, like extremely severe cramping and vomiting, and maybe you're on the toilet and everything else for, like an hour, and then that's the end of it. And maybe you fall asleep and sleep for the whole night. When you wake up in the morning, you feel just fine. And that's because the poison has come out of your system and also circulate your system and broken down. But that's actually not what the problem is. You don't die from the poison being in you. You die from the destruction to your organs. So like your kidneys and liver. And what actually kills you is the buildup of bilirubin and other toxins that you make in your system that can't be detoxified by your kidneys and liver. So after 24 hours and more, you start noticing your skin is getting yellow and your eyes are getting yellow, and you're basically poisoning yourself. And so you have to get to the doctor for dialysis. And if it was a bad enough episode of poisoning and your liver is really shot, you may have to have dialysis the rest of your life if you can get a liver transplant. And this has happened lots of times, so it's well documented in science. So older books said that the death rate of poisoning from this mushroom was like, I don't know, 80% or something. That's gone down over my entire lifetime to the point where now it's thought to be maybe 50%. So what that means is dum-dums eat this thing all the time and get poisoned and somehow survive, but probably nobody knows about it. Maybe they don't go to the hospital or something, but for sure it's not something to take lightly. And deaths almost never happen in Europe. And the reason is because people there know mushrooms so well, they know to avoid this mushroom. And even if someone did eat the mushroom, doctors know about this. It's so well known that they know immediately what to do to start treatment on someone. And there's almost never someone that dies. When people die from mushrooming in Europe, it's usually people picking king boletes. And the reason is because Italians don't like to reveal their spots, so they go out before dawn and pick all the king boletes and sometimes walk off of cliffs. Yeah, and that's well documented in literature, by the way. And it literally says that's what they died from. Yeah, but Europeans, especially Italians, don't die from eating poisonous mushrooms because they know them really well. Their families do it and they're very well educated. Any other questions? Yes, Andy. Yeah.
Regional or variants and the level of toxicity of different geographic groups. Do you know where that is at? Or do you know anything about that?
Don't know anything about that, but that stands to reason with a lot of mushrooms. With death cap, you'd kind of think that they should be all the same because there's been just a few. The story on the death cap is it entered North America on the West Coast several decades ago, probably through one single episode or maybe 2 episodes, and then it entered again a couple decades later on the East Coast. So in all of those cases from Europe, it's a very common species in Europe. So you'd think any varieties that normally occur, which has how organisms are, you'd think that there would not be much variability. I wouldn't, anyway, coming into the new world, but we don't know unless someone looks into it. And it could be terroir, it could be the type of soil or the host or, stuff like that. But I just don't know. We'll have to ask her. Yes, ma'am. No. So on the West Coast, Amanita phalloides came in California in, I think it was something like the 30s or 40s, and then came into BC in like the 60s or 70s and came onto the East Coast, something like that as well, something like the 70s. So not terribly long ago, and spreading everywhere. No, actually, no. I think that their thought, in the case of BC for sure, it came in weirdly enough on European linden trees, Tilia, which is a kind of a weird host for mycorrhizal species. Not that many things occur with Tilia. Tilia is, if you have linden trees around and they have really small leaves, kind of a compact tree, they're very common in cities. That's European or little leaf linden. Our native linden, or basswood, has great big leaves. And I think there's probably native basswood out here. For sure in the Midwest, it's very common. So it came over on little leaf linden. In BC, I've seen it on European beech. In North America, our Native American beech doesn't have a lot of mycorrhizal species like some oaks or whatever. In Europe, European beech has all the species. It's, for some reason, it really hooks up with lots of mushrooms. So those two European trees, I've seen it on. I know it's spread to Gary oak and tanbark oak as native species in the West. I forget what it came on the East Coast, how it entered. It's on some conifers on the East Coast too. So, I mean, it has a wide range.
What is the impact on the forest?
Yeah, so anytime you have any kinds of invasive insects or any invasive organism, it can displace things that are the native species in that niche, because competitive exclusion principle says no two organisms occupy the same niche. So something comes in and is successful, well, something else gets forced out. So we don't really know about invasive species of mushrooms coming in, if they have an effect or what effect they have. You would imagine that they would have an effect if they're very successful in forcing out native mycorrhizal mushroom species that occupy the same niche. Those could go by the wayside and go away. Okay, well, they go away. What's the big deal? You still have something partnering with that tree. Well, maybe those were partners with some other rare tree and nothing else partnered with it. So then that could bring about the removal of that species of tree, and that species of tree served as refuge or food for some other things. And before you know it, these ecosystems start getting more and more simplified. And we already know this is happening in lots of cases. So, and eventually you probably get to a point where once an ecosystem gets so simplified, maybe the whole thing collapses altogether. That's a real concern with habitat loss and loss of diversity. So it's just a big experiment going on right now. So tune in 100 years and we'll see what happened. Yes. Oh, well, so the free living Amanitas, I mean, you can tell them. They usually wear tie-dye, beads. It's all good, man. No shoes. Basically, it looks like most of the people at the Telluride Mushroom Festival. Yeah, they're free living. So up until recently, it was known that Amanitas were mycorrhizal species. Turns out they're not all mycorrhizal. There's a few, and the discovery of this really came from the Pringle lab with a student of Anne Pringle's, Benjamin Wolf, who was working on this one species that I think occurs in eastern Colorado, Amanitas. It for sure occurs further east into Kansas and Nebraska and down into the Gulf Coast area. Anyways, for years, this weird lepiota, that's not a lepiota, that's an amanita, occurs on lawns with no trees around, and no one knew how it could do this. There has to be a tree host. Maybe it's like a mile away. Maybe the roots are that long. Well, in the Pringle lab with Ben Wolf, they literally grew this thing on grass clipping agar. They basically made Petri plates with grass clippings in non-nutritive agar, and sure enough, you could grow the mushroom on this sort of thing. Okay, so for sure it's a saprobe. It doesn't need a tree host. It's not mycorrhizal. Well, how is that? Okay, so they started looking for genes that break down cellulose. I mean, that's where I would look. Fungi that can break down cellulose have cellulase genes. This shouldn't have it because Amanitas aren't saprobic. Turns out they do have cellulase genes. This was a major discovery. That's how it's saprobic. And it's known to break down plant cellulose. You need 3 different groups of these cellulase enzymes. It could take me an hour to explain why, because there's different types of cellulose bonds and things. But in any case, 3 different groups. And sure enough, this Amanita tiercii has it. Do other Amanitas have this? So they start sequencing lots and lots of Amanitas. And sure enough, the most closely related few species of this free living Amanita, the closest species related to it, they all had the same thing. They all had 3 genes for 3 different types of cellulase enzymes, and they all could be grown in the lab without a tree host. Pretty cool. But what was weirder still was almost all the other Amanitas they checked also had genes for cellulase, but not all 3 groups. So closer relatives to the free living ones maybe had a couple genes for a couple of the types, but not all 3 types. And then more and more recent arrivals had maybe genes for 1 type of cellulase. And then the most recent arrivals, the most recent Amanita species had none. So what they reasoned is Amanita came from an ancestor that was like Pluteus. You know, it was a saprobe, but somehow through a mutation lost the ability to break down cellulose. And this probably happens all the time in saprobic mushrooms. And guess what? You don't have the ability to break down cellulose. You're a goner, and that's how mutations work most of the time. Most of the time, genetic mutations are lethal, you know, because everything's pretty well fine-tuned. But somehow there was a species, an individual, that somehow glommed onto a tree root and was like a parasite and could eke out a living and made spores, and its progeny that did the same thing could eke out a living as a parasite on the roots of the trees and got better and better at it, and you know, speciation and etc. Now you have lots of species that are parasites on tree roots, and over time these fungal parasites of tree roots not only don't harm the tree as much, or maybe over time don't harm them at all, maybe after even more time somehow benefit the tree, because that in turn benefits them, and mycorrhizae was created. And we know that mycorrhizal lifestyles have evolved numerous times. So like all the mycorrhizal mushrooms that we like, chanterelles, russulas, boletes, they don't come from a single common ancestor necessarily that was mycorrhizal. Lots of groups have evolved mycorrhizal types independently numerous times. And we know this because a lot of the different mycorrhizal types, the way they glom onto the tree roots or what goes on inside, the association is radically different. So it's happened numerous times. And it's probably how it happened in the Amanitas. They started from saprobic types and became mycorrhizal. And that was the like 2-minute overview of this study. If you read the paper, and assuming that you know some stuff about mycology and could get through the paper, it's an incredibly brilliant, elegant study. It's one of the greatest studies ever by this grad student in Ann Pringle's lab, who then decided, well, you know what? I'm done with Amanitas. I think I'm going to study fungi that make cheese. And so then he came up with a way to like DNA barcode all the cheese type fungi for all the French cheesemakers. And they threw millions and millions of dollars at him. And then that wasn't enough. After that, he's like, I'm not going to work on cheese anymore. I forget what he's working on. He went overboard on all the fermenters. He went to the dark side. So we don't like to talk about it. So this was a very brief overview of a really cool group of mushrooms. If you did want a copy of the Amanitas book and you wanted it signed, or even if you didn't want it signed, the cover price is $60, but I have some here for $40. And also, you have free magazines. Also have one copy. But if you want to see what it looks like before you buy it on Amazon, I have a copy up here. It's about all kinds of fungi, like basic beginner stuff about fungi, and then stories about the wackiest, craziest mushrooms and other fungi that you've never heard of. No one in this room has heard every one of these stories. It's not possible. It's just not. So is that it?
Thank you. Thank you all for coming, and like you said, he'll stick around and sell some books and sign some books and talk. And next month, we do have Mark Donsky, our own Mark Donsky is going to be talking about some of the chemistry with medicinal mushrooms. So thank you for coming.
Thank you. I guess we're not going to go over the blue Amanitas, are we?
No, I love your shirt. Oh,
It's on my store.
I know. Can you make small enough for me?
I think we can probably do it smaller.
I need extra small.
I need triple extra big. Sure, you didn't get a help now.
No, it's women to be fungi. Yeah. Yeah.
Yeah, so the group that I do feelings first with, they also